Good day. My name is Maxim Mozgovoy. I'm very happy to be here. And today I want to share with you my experience of building my own multi-platform automated software testing facility. So before we begin, just a couple of words about myself. I live and work in Aizu, Japan, and my primary research area is human-like artificial intelligence for computer games and simulations. So what's so special about game AI is, let's say, its specific goals, which are different from regular AI systems, because all games are about experience for the users, and this experience, let's say, supported by AI can be vastly different. So your opponents controlled by AI system can be strong or weak. They can behave in a sort of erratic way and so on. So there are all sorts of AI controlled characters you want to have around. So it needs to possess other qualities, let's say, rather than just being good. And also, in addition to that, I have really a strong interest in designing practical systems, in doing something with my hands, let's say. And I also had previous industrial experience working as a software engineer. So, and exactly this combination of factors brings me to the today's topic, which is really tightly bound to them. And let's say, because it's going to be a rather long speech, I think I can uh, construct it as a sort of story, as my personal story of my personal experiences, and I hope that it might be of interest and it might be useful for you. So how it all began. Some time ago, or actually already several years ago, I got a phone call from my old friend, and he said that, look, I have a new plan which you would love. And the plan sounded like that. So you have your AI research. You are working for that for many years at the university, and I know that your results are quite good. And he said, I'm now creating a new team, a new game development studio. So we're hiring the best people, and we're connecting the um, our friends around who are good specialists. So then we can create a great game, which of course will be accepted by the public and get it's like universally acclaimed and so on. And then we will get rich and live happily ever after. So he said, how can you refuse such a proposal? Well, I said, probably I cannot. So then here all my, let's say, adventures began. So what we did to some extent is we created a game of tennis, so that I can show you some screenshots of that, some video clip. So indeed, after some years, so it took us some years to make it fully. So it's currently released on a number of platforms. So it says Win, Mac, Android, iOS, actually also Nintendo Switch nowadays. And we get already more than 1 million downloads and got quite good reviews, and so on. So I think it was a success. On the downside, I cannot say that it really was universally acclaimed and brought us a lot of profit. So we're still working on that. And we released it with considerable delays, which I think in our industry is norm, unfortunately. But still, it's a project that we managed to finish, which I'm happy and proud of. So, however, the next question is, what are we going to do next? In the modern software development and in game development, you can never stop. It's not like you release the software, it hits the market, and then you forget it and switch to something else. It's usually not what happens. Usually nowadays, software is getting regular updates, and if you're already somewhere in the top of, let's say, Google Play ranking, then there is a motivation to stay there. And if you just leave your product without any updates, and you are not actively working on new customers, and obviously there is always how to say, an stream of new people who get their smartphones maybe first time in their life, or decide to play some computer game first time in their life. And for them, there is no difference whether a certain game is released now or 10 years ago once it's popular. But to keep it popular and to keep it updated with the time, you really have to work hard, and you really have to work on increasing your user base and on keeping this game, how to say, updated, and keep its modern looks and so on, align with the times, let's say. So that then this friend of mine said, well, how can we now establish, or how to say, ensure let's say sustainable development of our software. How can we keep it running and continue to improve it, so to little by little increase its market share and improve user perception. So then, of course, we talked about this, which was quite well summarized by Joel Spolsky, that nothing really works better than just improving your product. So we decided, yes, that marketing is important, and keeping new functionality is important. But basically, what we do is we um, want to have some little improvements here and there all the time, at least. But what is also quite special about game projects is that maybe not only game projects, but all the projects nowadays is how the user perceive them. So when Joel said that we should improve our product, the next question would be, of course, but how this improval should be manifested. So what should constitute these improvals? And then if we look at the literature, it actually says quite clearly what kind of features or what kind of situations are perceived by, especially bad by the users. And then we see that according to some research which I looked up, the users especially complain about functional errors, so basically bugs in the software, and also app crashes, which you see together constitute maybe more than one third of all the troubles people encounter with. And that's why uh, they write negative reviews and then down rank your app. And the reality is, when your app is located in the online store, such as Google Play or Apple App Store, this ranking algorithm, it will not only provide, how to say, it will not only react to the keywords users write down to search for something, but also they take into account the ranking or the ratings of the app. They take into account uh, the amount of stars people put, and even they consider crashes, because every time your app crashes, at least on Android smartphone, then Google immediately knows about that. And more crashes you get, then lower rank you will have. So that's why it directly affects your position in this list, in the search list, and this is very directly affects your profits, because in this market, let's say the games from maybe top three, or any game from top three in certain category can make more money than all other games in top 10 combined. So it really works like in this winner takes it all scenario. So that's why working on improving your ranks is quite an important goal. So also, I'd say that if we decide that we want to improve it by removing bugs, by working on extended functionality, that you can see that it's not so easy, because games are, in despite their, how to say, fancy looks, from software engineering point of view, they are quite complicated systems, because a typical modern game, it has separate front end and back end. Front end is what the user sees, basically the game itself. But then if the game is, let's say, multiplayer game, it definitely has a back end server which keeps say user profiles, it keeps leaderboards, it keeps certain other user data, it organizes matchmaking, it organizes everything related to billing, related to transactions, to in-app purchases, all this stuff. Also, all games do actually do some sort of user analytics, which can be quite innocent. Like in our case, for example, we keep track of what kind of, let's say, functionality users need. So, for example, suppose in our game we have, let's say, a feature called locations. So you can have your base in England or in Australia or in, let's say, France and or in Japan, and they look differently, but functionally they're the same. So it just is visual sugar. So suppose we want to add a new club to this list. So we want to add, let's say, I don't know, Scandinavia. So the question is how actually important this is for the users, how often the users change the default club, and actually how diverse are their tastes. And then we can look at user analytics and see if they indeed like this idea of switching clubs, or it just basically wasted money. So same analytics come, for example, to tutorials. So if we are interested, if the people are getting stuck on a certain tutorial steps, and then we can see that probably the tutorial is not good there, so we can rework it or improve it and make the game easier and so on. Then, of course, there is a huge amount of work invested into billing transactions, all these things, and integration with systems like ad providers. Because even if games have in-app purchases, I think you know that only a very tiny fraction of people actually buy anything in such games, and that's why considerable amount of income comes from ads. And that's why to integrate ads into your system, you have to deal with third-party software designed by these ad providers. So unfortunately, we have to often have to rely on quite unstable third-party libraries and tools. So again, in, let's say, classical software development, usually there is no reason to uh, roll out into production something which is not tested or not stable enough. So when again, as a university teacher, I usually tell the students to be quite conservative with new technologies and new tools. But unfortunately, sometimes we're just pushed to do it. So last slide I mentioned this integration with ad um, providers, and these ad providers sometimes roll out new versions of their SDKs, of their libraries, and they say that you just absolutely must upgrade to this version, otherwise it won't work, because we are switching off support for the old version. And unfortunately, quite often it happens that this new version is unstable, and it gives all sort of headaches for us, but we have no choice. If we want to have these ads in the game, we have to switch to this new version. Also, we have to update the game regularly. So let's say when Apple released this iPhone X or 10, iPhone 10, it got this sort of indent in the screen. And then all the apps initially looked like this. So they could not use this area nearby. And of course, it looked quite poorly on this screen. And that's why we had to forget about all our normal workflow and start adapting the game so it can use this whole screen, which again caused us or forced us to upgrade to new developer tools, which actually can make use of this capability. And we had to deal with new bugs and issues in these new freshly released um, components. So we have no choice. So it all means, and yes, yeah, not yet. I'm saying all means, but let me conclude later. So there are more into that. So we obviously have to run this game on diverse hardware, diverse software platforms. So it's quite clear that a Windows machine is not the same as Nintendo Switch, let's say, or iPhone. And then there are issues which are quite difficult to test automatically. So games are rich in animation and graphics and sound. And also I can add to that that usually these components are very tightly coupled with the primary game engine, because again, if we look at a classical software engineering approach that we teach to students, we usually tell them that it's best if we can separate independent concepts. So, for example, if it can separate UI from this core functionality. So it's like a model view controller. So there is a model which is a basically core component of the system, and there is just a view, a presentation layer, which can be theoretically separated from the model, and then we can test model independently from view. But in games, at least in modern games, unfortunately, it is not so. Let's say if we have a character moving across the game field, and suppose I want to know where, in which location this character will be after, let's say, 10 seconds of a game, considering that this character is moving with the same speed and same direction. So unfortunately, this particular functionality is tightly bound to game physics, which is in turn tightly bound to game animation. So because the actual movement of this character depends on a particular animation sequence. So how the legs of this character are moving exactly, and how the steps look like. And this system is basically one individual whole. So it's only possible to have an accurate prediction if we really simulate all this animation. So we cannot just switch off the animation and say that we only want to have game physics without animation. Usually we cannot. So also I can say that it's um, these games have this amount of, let's say, large proportion of code which is hard, which has high cost of unit tests. And what I'm talking here about, maybe I don't know, many people have, if many of you have the same experience as me. I don't know how large is this proportion, but I certainly have this experience. I always had a feeling that on one hand, testing like unit testing is a very good idea. On the other hand, sometimes introducing unit testing that covers a lot of my code is just very, very expensive. So it takes me a lot of time to write these unit tests. These unit tests happen to be fragile, and also the say yield is not so high. So I get some profit from this unit test, but I don't really feel that I'm going to make a mistake in this place. So the um, chance that this unit test will catch anything is quite low. And then once I stumbled upon an article, actually a blog post, this number 3 in the references, which try to classify these different types of code into different areas. And the author tried to argue that indeed you can say that this sort of this sort of testing is not the same for different types of code. So let's say if you have something like classical algorithms like this, so this is a perfect match for unit testing, because this input and output is very well defined, and also you can quite easily make a mistake, and the unit test is very likely to catch this mistake. So that's why if we have something resembling library code, resembling this purely algorithmic, let's say, system, then it perfectly makes sense to design an extensive using unit test for this type of code. And also, let's say, but the rest of this scheme is already not so obvious picture here. So for example, we have trivial code, which is easy to test, and also so we can write a lot of tests in short amount of time, but also the benefits are quite low, because I don't think that unit tests will reveal anything, any sort of mistake, and sometimes the code for testing can be more complex than the code we test. And then suppose we have coordinators, which is sort of glue that brings together different parts of code. So we have one subsystem, another subsystem, third subsystem, and then we have certain code that tries to bind them together. And in this case, this code, it tends to be quite small and quite simple, but because it deals with complex interfaces of complex subsystems, then designing such code can be quite difficult, because we will need to mock a lot of objects and a lot of APIs. And also, this is maybe the worst, is some code which is overcomplicated. So it means that, yeah, we can say that it needs refactoring, but now we're not talking about refactoring. It's there. Yes, the code is there, and we need to do something with that. And it might be true that it's difficult to test such code because the logic of this code is overcomplicated. So it's extremely hard to find out all the possible branches and all the possible inputs and outputs. So both the so the uh, cost of writing such tests is very high, but also the benefit is also can be quite high. And unfortunately, I would say that in games, because of this previous issue I mentioned, that we constantly have to update it and we constantly have to deal with this diversity of platforms and complicated game logic and untested or poorly tested third-party libraries, which sometimes require hacks, I'd say, and workarounds, then games quite often have a lot of this overcomplicated code, which is difficult to test. And also, games have a lot of coordinators because we have this clearly defined subsystems such as user input, network, graphics, music, all these elements, and there is a lot of trivial or nearly trivial code that simply coordinates between these subsystems, and that's why it's hard to write this. So it means, you see, it means that the all what I said so far, I think it quite proves that games are prone to bugs because we are constantly chased by this life, let's say, life realities. We have to uh, forced to adapt our games and to introduce newer and newer functionality and to keep existing functionality running and to upgrade to newest tools and mm, um, let's say libraries and SDKs. And at the same time, we know that if this update causes us additional crashes, that it immediately hits us hard. Because the users won't tolerate it and they will downrank the app. So that's why we are sort of mm, stuck in between. Yes, we cannot really, our um, elbow room is very small. So we must go on, but at the same time, we must ensure quality, which is very difficult. And that's why what we decided to do is we thought, well, but how can we improve the quality of our game by at least ensuring that there are as few bugs as possible. So, because as I said, the unit testing is especially difficult in games, then we decided to make our primary emphasis on testing the complete game as a resulting system. So extensively test what we have on the output. And also we think that we could achieve, it was a quite a successful idea to achieve certain synergy of different tools which work together and help us to reach this goal. So let me quickly go through some of these tools and then come to the main part. So one tool that we actually embedded first in the game was Firebase Crashlytics. So it's a reporting service which reports to us all the crashes of the app via internet. So it gives us the stack traces. So in many cases, we can identify what was the reason of this crash. And how it works, if the game has this tiny piece of code from Crashlytics embedded, and then when the game exits normally, then Crashlytics just does nothing. But if it's cleaned up. But if it exists abnormally, then next time the user runs this up, Crashlytics understands that last time it was unclean exit, and then it reports this um, stack trace and additional diagnostical data to us. And I'd say that the most maybe primary yield we got, the primary result was uh, identification of devices with insufficient memory, because we have quite many devices on our hands, and before releasing the game, we could test more. Quite many types of bugs, but of course we could not test all of them. And one common situation was exactly running the game on a device with just too little RAM. And it's nearly impossible to detect it beforehand and somehow prevent crashing because on mobile devices we don't have this access to free RAM and we don't know how much RAM is left and what will happen if we are about to hit this limit. So we could identify it and at least say that our game is not supported on such devices. Then another tool that we developed mostly ourselves is the system of automatic and manual bugs. So automated bugs is a facility which reports us a certain situation when a certain assertion is violated. So typically when we talk about assertions, we mean, let's say, this hard assertion. So if assertion is failed, then the system crashes immediately or exits immediately. But in our case, we have many situations when the user won't even notice that something bad happened. So, for example, we believe that according to game physics, the ball in tennis game should never fly higher than a certain limit, let's say 10 meters. And then at some point, we detect that the ball is actually higher. And it should never happen. So, in again 99% of cases, it won't cause much trouble so the user won't even notice that the ball is higher than it should be, but we immediately get the situation reported, and then we can investigate it further later. So we had quite many of situations like that, and they proved to be very useful. So it means like non-fatal asserts. And also we got these, let's say, user tools for bug reporting. So we implemented a certain feedback interface where the user can just push the game on pause and immediately write down anything which they consider wrong. And I'd say that this interface was mostly targeted not for the end users but for our beta testers. So, and they indeed could identify a lot of bugs which are difficult to test automatically. So, for example, one clear case was um, when the character is standing in the club view, so you just in the beginning of the game you see the character doing nothing. So your tennis player just waits for you to press start button, and then you could see that the feet of this character is actually deep in grass. Because in the previous release, the game designer, for some reason, for some mistake, shifted the character say 50 centimeters down. And characters' feet previously were on the ground surface, but now they are below the ground. So it's not even, how to say, not even obvious. It doesn't really jump into your eyes. So if you run the game, you maybe not even notice that. But somebody, some our beta tester noticed, and of course they immediately reported to us and say, look at this screenshot. So that's what happened. And then finally, this is the most important part, and we are coming to the main topic of today's discussion. So that's this automated smoke testing facility. So what is smoke test? And there are many words about of similar meaning, like canary test or yeah, smoke test, and or there are some other I forgot. So the basic job of this testing is to ensure that most subsystems work. So you run the app and perform some very, very simple test scenarios. So in the beginning, you can just ensure that it doesn't crash while it starts up. And according to Microsoft, one of the sources I found, it says that it's the most effective, cost-effective method for identifying and fixing defects after code reviews. So it's indeed one of the most helpful tools because if anything goes wrong, then this automated testing will fail and we can investigate further what happened. So uh, I believe that if I jump to the conclusion that I can say that it was indeed a good idea, and I think that for our future projects we are now working actually on our second game, we start using this smoke testing quite early in the development cycle. So we believe now that they are quite an essential part of our work pipeline. So I think it was a good experience and reasonable investment of our efforts. So this smoke testing facility looks like that. So I mean, sorry, it's not the smoke testing. It's a regular facility, which I think it's very typical for many software development companies. So we have this repository, and here is our code, and then we have some contributors, people who actually write the code, and then we have automated build machine, which typically produce several builds daily. So every time somebody makes a commit to the repo, then we get this automated build, and then we it produces this ready game for a variety of platforms. So now I can say that even that system, which is again, as I say, typical for most companies, they already ensures some sort of quality assurance, because we know that this game can be compiled, and build machine can compile it for 5 different platforms, because usually the developers have no time and energy, and sometimes they don't even have this uh, possibility to test if the game can be compiled on all platforms. So for example, in order to compile the game for iPhone or for Mac, you should possess a Mac machine. So you cannot compile it on Windows or on Linux. Well, there are ways to do it, but they are not official and not officially supported. Yes. Then the next level, what we must be sure is that the game doesn't crash at startup. And this actually happens more often than one might think, because sometimes it's just due to compiler errors. So sometimes if we have this previous build, so there are some pre-built pieces of this system, and then the linker puts them together along with the new changes, and then something goes wrong in this pipeline, and then we get a build which looks like normal, but when we run it and it crashes, and then we make a clean build and then it works fine. So it also happens sometimes. Then we can ensure that this game can connect to our backend server. So you see, this already can be considered a simple smoke testing. So we run the game and we make sure it does not crash, and then we make sure that it doesn't print out a message that it cannot connect to our backend. So we know that both our front end infrastructure is running well, our backend infrastructure is running well, and the game at least was able to initiate a handshake. So it had this exchange of some initial data, and it was successful. So it's already something. It's already not that little as one might think, because sometimes it happens. And I'd say that maybe the most important result we got in this facility, or thanks to this facility, is early detection of bugs, because people constantly make these changes to the repo, and it's very crucial for us to understand which change exactly caused the fatal malfunction. So if we test the game, say, once in 3 days, then there can be dozens of commits that could have made this trouble. But once we test automatically, at least somehow test this every build in the system, then we know exactly which build is faulty. So initially, that friend of mine who is our project manager just told me, well, when I asked him what he wants to get, he said, well, it's easy. Just let's see that the game doesn't crash and is able to go online. So exactly as I said in a couple of minutes ago. But as you might imagine, it was just the beginning. And once he got this running, of course, he wanted more and more and more. And after 1 year, what we actually have is every build goes through 6 different scenarios, and every scenario takes around 30 to 60 minutes to complete. So this testing is quite extensive. Um, and then what I want to say about this testing, um, again, some points which are related to the current testing system we have. uh, that first, what we like is the testing system just relies on ordinary user end UI. So there is no hidden interface, and we actually introduced very few hacks into the game to make sure that it works, this test and facility, but otherwise it just follows ordinary user interface, so our programmers don't need to think how to make this game compatible with testing facilities. So there is no such need. And then also what is especially cool, I think especially cool, is that now our tools work in synergy. So automated test doesn't need to test everything. It just needs to run the game normally as users do. And then this system of crash latex and the system of automated bugs, they generate these crash events, and they generate us these soft non-fatal errors and report to us, and then we can analyze not only the report created by this automated testing facility, but also with our previous tools, which I mentioned before. And currently, I can say that we run it on several devices, 3 Android phones, I think already 4, and 3 iOS devices and 1 Windows device. We also can do it on Mac, but not yet. And also, what is really cool that in addition to bugs, these tests can report some stats. So, for example, because it's a game, we are interested about frame rate and about memory consumption. And we have this variety of devices in our test farm, and the game also have a lot of modes. So you can imagine that once you load the game and you just see the character doing nothing in the main view, uh, frame rate in this view can be quite different from frame rate in actual game inside the game process. So that's why it's quite important to check different screens, different pieces of interface, and make sure that all of them are quite fast, that none of them cause frame rate slowdowns. Also, same can be said about memory consumption, because the game consumes different amounts of memory in different modes of operation. So also what we can do and what we do from time to time is we sometimes run our tests for extended periods of time, like several hours. So this is to ensure that the game can be run sufficiently long, and there are no memory leaks and other troubles which can occur after some time. So they can pile up and then cause crash. So, for example, one simple scenarios, let's say, which our auto testing capability facility can do is, let's say, it can load a game, so that's a loading screen. That it can go to this main screen, close this hint, then it can go, let's say, to this main menu. That's a button, and then it can go to this coach button, coach tab, and in the coach tab, it can go to coaches tab, then it can try to hire this coach. So it says hire, and then this coach is hired, and then we can go to uh, training mode and actually start training with this coach, and then we can just randomly click around the court to make sure that we can play this match, and clearly it ends with my loss because I just click randomly somewhere, but at least it doesn't crash. Then I can click OK and go to the main menu. So there are some additional interface elements, and then I can go again to this main screen, and then I can now play with my newly hired female coach, this one. So I can do this mirror training mode and then continue the same for the mirror training. So here I even managed to score 2 points, as you see. So this is how it works. Then I can watch match review and so on and so after. So it might be quite complicated. And you can see that there are other scenarios that we do, something like pass tutorial or customize player skills, link a Facebook account. So this all can be done automatically, and it is actually done on our devices. So the question is how to achieve it technically. So there are two pieces in this puzzle. So one piece is software and another is hardware. So speaking of software, it means that we will need to write test scripts which actually do this job. that click these buttons and switch tabs and simulate game process. And also we need this device farm, the collection of devices connected into a sort of unity that are used to run these tests. So let's say there is certainly an easy way, and what I'm talking here about is quite an important and topical issue, and that's why companies offer ready-made solutions. So you can go to sites like Amazon or Bitbar and just subscribe to their services they offer exactly for this purpose. So it's easy to set up and they provide thousands of devices to do. On the downside, it is quite expensive. So these prices vary. So I'm not saying that the prices is like this for today. So I think now they are lower. But in general, what they do is they give you, they charge you for device minutes. So the longer you use a certain device, the more you are charged. And if you use 10 different devices, then of course you have to pay 10 times more. And at the same time, while they have thousands of devices, still the choice is quite limited. So, for example, they might have a lot of phone models made by Google or by Samsung, but say no phones made by Huawei or Xiaomi. So sometimes they are very tightly bound to certain manufacturers. And then there is one, it's neither advantage or disadvantage, but it's just a matter of fact that different platforms usually have different scripting languages. So if you write a test for certain a platform, that it's very likely you won't be able just to transfer it verbatim. So you will need to adapt it to another platform. So, but that was the easy way, and as you can guess, I was not looking for an easy way, so I decided to make the device farm myself. So how we do that? So of course there are also pros and cons for this approach. It's flexible. We can choose any devices we need, and that's what we do. And it means, of course, we need to buy them. But usually I just buy them secondhand, and also I can tell you that in most cases, what I target for low-end sector because usually our developers they already have devices of current generation on their hands, so they can test whether game runs on, let's say, iPhone, which is close to today's latest model. But the question is, of course, in the low-end sector because people usually don't keep their phones for such long time and but it's essential for us to test on low end too, and it's sort of win-win because on one hand I test a game on these low end devices and on the other hand I can buy them cheaply on the second hand market. And in the long run this farm is quite inexpensive, so I think comparing to Amazon or Bitbat services it was quite a money saver for us. On the downside, of course, it's still limited to few specific devices. So I can buy 5, 10, maybe 15 phones, but perhaps it's out of our budget and just not very reasonable to buy hundreds of them. And indeed, I think that just having the amount of devices we have now, something like 7 or 8, is quite sufficient. And it unfortunately also requires regular maintenance. So maybe this is the worst thing: is you cannot just make it run and forget about it. So you need sometimes to perform sort of maintenance of this farm because devices are not really designed to stay online for that long. So for example, one trouble I get regularly is the batteries, they came out of order. So they become like swollen maybe every several months on some devices, and then I have to change the batteries, let's say. Or sometimes devices need to be rebooted, or sometimes devices need to be updated, especially iPhones that I especially hate it because every time it detects that a new operating system is released, then they show the snack screen. Please update, and until I close the snack screen, until I update it, that I cannot run any tests because tests fail and tests fail because they wait for user input on that NAC screen. but unfortunately this cannot be helped. So the minimum setup, just from logical point of view, in this device farm looks like that. So we have this test runner. So it's a device running the test script. And then there is a device which interface with the target platform. And then it's finally the target device. So this is a logical separation. Physically, you can have both the test runner and test server on the same machine. So a minimum, you need at least one desktop device and one mobile device to start running these tests. So speaking of software, uh, I can say that on the phone there is nothing which is required. So there is no need to install anything specific on the target mobile platform or a target Windows Mac. So it's all built in into these systems. Then on the server, on the test server, we need to run a certain third-party testing framework. So here I said like we chose open source Appium, which is available here, but now I cannot even say that there is much choice because previously we could choose at least one of two competing frameworks. One of them was Appium and another was Calabash, I think. Yes, Calabash. But now this Calabash is closed as far as I remember, so only Appium is left. I'm speaking about this multi-platform framework. So if we are interested in just some specific platform, that the choice can be wider. But for multi-platform testing, I'm afraid that there is nothing except Appium which fits all these needs. And the test runner, it basically runs test scripts that are written using in a conventional programming language supported by the framework, which it means by Appium in this case. And in case of Appium, it supports quite a variety of languages. Most popular of them are probably Java and Python. But it also supports Ruby and others, so they have these language bindings for different programming languages. So personally, I write these tests in Python, but I could have also written them in Java. So how these tests look like from a programmer's point of view? Well, technically, they just look like code like that. So we can get to Appium, then I can try to find some element. Let's say I want to find an edit box, and then insert this edit box, I want to type something, and then I can try to find an element such as a button, and then I can click on that button, and then I close this input field. So this is the typical piece of code which uh, performs user input into this input box and presses OK. But in our game, unfortunately, this approach doesn't work in most cases. So sometimes it does when we input username. Let's say when I run the game first and I ask the user to provide a name, then I indeed use a fragment which is similar to the one above. But in most cases, what you saw is this hand-drawn interface. So when you see these buttons and the tabs on the game screen, in reality, they are not treated as buttons and tabs by the Android or iOS system. It's just the one drawing area, and they are all simply drawn on the screen by the artist. So that's why the most maybe practical, feasible approach is to use image recognition. So let's say if I want to uh, uh, click on the input box, and the input box just looks like a red uh, let's say red strip of pixels. So I can try to find the picture which matches this input box look, and then I find the location of that, and then I can try to click on that location, and after that I can, let's say, find OK button picture, and if I can find this picture, I can click on that. So, and then we can fail the test if it's not found. So that's why, unfortunately, in our case, we really have to rely on image recognition. So this is exactly what I'm talking about. So suppose I want to click this input box, and then later I can input a username, and after that I find the picture which is similar to this one, and then I press OK. So We use it with OpenCV capabilities, and of course, you may ask what's the reason for OpenCV, while what we do is we just match individual pixels. But unfortunately, it is not so simple because the actual rendering varies from device to device, because devices or game settings, they cause some smoothings, for example, and also screen resolutions are different, so this game screen can be stretched or compressed to match the device screen. And that's why these graphical elements in reality are never exactly the same on all the platforms. So we can talk about approximate matching, but I cannot really ensure that there will be a perfect one-to-one correspondence between my template pictures and the pictures on the screen. So they are always slightly different. So that's why I need approximate matching, which is established by OpenCV. So in our case, we really integrated all these scripts into this whole building process. So in addition to the previous stages, when we have this repo and then we have the build machine, we now also have the testing server, which regularly checks if there is a new build available, and if there is a new build, then it tests them with all the testing scenarios we implemented, and then we summarize results and publish them as a separate HTML report. So they are, because these tests take a lot of time, we do not keep them as a part of the building process in the way that it's a stage of a building process. No, it's more like there is a ready-made build, and then this testing server works in parallel, and it provides a separate report. So that's why this building machine is one thing, and the testing machine and testing reports is a completely different thing. So then the testers look at these HTML reports, and then they try to see why certain tests fail. So what is also good in these reports is they contain screenshots from the game process. So that's why we sometimes ask our testers to also look at these screenshots and see if they see something suspicious there. So previously I mentioned we had a situation when characters' feet were below the ground level. And nowadays, the testers don't even need to run the game to find glitches like that. So they simply can look at the test reports and see if they notice something like that. So you can really just go through these HTMLs without running the game. So now it looks like that. So this is the modified pipeline. So we have this separate game building process and separate game testing process. So this is the current hardware setup that I have. I'm not sure if this is a bit outdated. Maybe I have 4 Android devices now, but in a nutshell, it's the same. So I have this test server, which actually is used to, I'm sorry, test runner, which runs the test scripts. And then I have 2 test servers. One of them is Windows-based and another is Mac-based. Why so? Is because there is a restriction. You cannot run tests on iPhones uh, on any other machine but Mac. So it's only possible to connect it to a Mac machine. However, you can connect Android to Mac. So if you are interested in the minimal setup, which supports both Android and iOS devices, you could just manage with one test runner and one Minimac machine, and then a device is connected. Or even you can run these test scripts also on the same Mac machine. So minimum would be one Mac Mini and also 6 connected devices. Just from my perspective, it's a reasonable setup. But what I do in reality, I run these tests concurrently. So it's not like I'm running the test on the first Android device, then on the second, then on the third, and so on. I run all of these 6 tests in parallel, and it's quite a heavy load. So if I run them all on the same little Mac Mini, that would be too much of load for this device. So that's why I decided to split them into several machines, and now it works quite fast. So physically it looks like that. So these are the servers. You see they're all little machines and they don't occupy much space. So I like how they're neatly organized here under my desk. And here are mobile devices that I have in the farm. So there are one, two, three, four, I don't know, five. I don't see all of them. Yes. So I think there should be another device hidden somewhere behind this Kindle Fire or maybe in front of it. So it's not all of them shown here, but yes, that's pretty much it. So this is iPad Air, and this is iPad Mini 2, and this is iPhone 5S, and this is some Xiaomi device, and this is Amazon Kindle, and also I have some other devices now. So I'd say that while I was creating this platform, this facility, I had to overcome some barriers. I really stumbled upon some pitfalls that were quite unexpected to me. So, for example, when I tried to let's say, okay, yes, one step back. So how I first decided to choose these specific devices which constitute this farm. So what we try to do is to focus on diversity of hardware to make sure that it works on different platforms and different devices, hardware devices, and get some low-level models, as I noted. And the reason is that sometimes code fails on certain GPU chips. So it means that if I get two different phones, what I look first is not just different manufacturers, but I look at the chipset specification. That's what I'm interested at. So I look at the chipset and I see that it should have a different CPU and different GPU from what I have already in the farm. That's what I do. And then another one, which was surprisingly tricky, is to choose the right USB hub because obviously I think it's quite clear that all these devices they are connected to the same USB hub. It's actually here in this basket. And if you just go to a hardware store and buy just some generic USB hub, you'll see that it's not designed to charge and to transfer data simultaneously. So if you run tests for some long time, you will see that devices will discharge. So and that's why this USB hub it must be able to provide enough power to keep them running and to prevent battery drain. And at the same time, it must ensure data transfer. And again, to my surprise, there are very, very few models of this sort on the market. So I could only find one manufacturer, which is called Pluggable. And on that Pluggable, it indeed made the trick. And maybe the worst is it's quite difficult to actually find whether a certain hub is compatible or not compatible with these goals. So because many hubs are advertised as charging hubs, but in reality they either charge or transfer and not at the same time. So that's why be warned, it's not that easy as you might think. Then unfortunately there are some quirks of particular devices. So initially I was looking at devices exactly according to the criteria I said. I want to have diversity of GPUs, diversity of CPUs, and maybe screen sizes and software version and so on. But also I see that some devices, for example, can install application only after several attempts. So you must try several times before it installs. Some devices do not unlock the screen, some Androids, so I have to keep them into developer mode and keep the screen unlocked. So some devices, I have one such tablet, it just doesn't want to charge from USB, only from a wall charger. And some devices, all iPhone devices actually, they require regular updates, and unless you update them, they block the tests. Also, in addition to that, I can say that some devices, um, this is a disease of Android, they actually never clean up the temporary folder. So when you do this install, uninstall, install, install loop, the amount of free storage on the device actually goes down, and even reboot doesn't help. So you need to run some commands, some scripts on these devices to clean them up and to make sure you have additional space. So that was absolutely surprising for me. But still, I can say that after again working for so long time with this facility, that it's well worth the effort, and we indeed could identify many new bugs. And maybe the best thing what we have is we have this sort of feeling sense of peace that came to our life because every time we create some build, there is this feeling of anxiety whether all the elements work fine, whether our testers are how to say are hardworking enough and not to be lazy to test all the scenarios that we ask them to test, because sometimes people cut the corners. They say yeah it works, but in reality it doesn't work. But this auto testing facility, it checks all the basic scenarios, and the odds are, if these basic scenarios work, that most probably the game also works, because if there is a major flaw there, that it almost inevitably pops up in on one of our scenarios. And also it's quite good for our testers as well, because they don't have to waste their time on these simple situations, and indeed they can focus instead on something which is much more challenging, much more complicated. So they do testing in a more smart way, let's say, than they used to do. So this way, yes, we are happy with this system, and I thank you very much for your interest, and please feel free to ask me about anything, so maybe I can help you with some, I don't know, building up your own farm, and also bring peace to your life as well. But that's all for now. Have a nice day. Thank you.